Hey, this is Patrick Sullivan. Welcome to my shop. Recently I started a wood project with complicated shapes where I can already see I'm going to have grain problems. It was clear that the safest course was to use small abrasives and burrs to remove quite a lot of wood. So I decided it was time to buy a really powerful flex shaft tool that could drive bigger cutters like these. The new motor is fairly heavy. It tends to jump every time it starts. I needed a stand that would hold the motor securely, but could still be positioned close to my work, regardless of whether I was standing or sitting. I also needed a convenient place to hang the handpiece. The flex shaft came with a foot pedal. This is an extremely convenient accessory because I often use both hands to stabilize both the workpiece and the handpiece. But the foot pedal is a trip hazard when the tool is not in use, so it would be nice to have a way to store it and its power cord in the stand as well. Over the years, I've accumulated a big assortment of burrs, bits, cut-off wheels, and abrasive tools designed for small rotary tools. It would be convenient to keep a variety of those close to the action, but just setting them down on the workbench is a terrible idea. They would rapidly become misplaced, maybe damaged, or even permanently lost with my sawdust. I mean, look how easy it would be to miss this bit amidst this debris. So it would be nice to keep a large assortment of bits in some organized way directly on the motor stand. Finally, I often use a face shield and hearing protection depending on the job. Why not have a place to hang those on the stand? My starting point was to build a box that I could fill with concrete to make a base heavy enough to resist tipping. The sides of the box were cut from 3/4 inch or 18 millimeter plywood. I cut a step-shaped recess, called a rabbet or rebate, in the sides to fit the thickness of the plywood. Adding these channels takes only a few minutes on the table saw or the router table and makes the glue-up and assembly much easier. It's easier to clamp, and the whole box wants to stay square while you're clamping and nailing. I used a few 18-gauge nails, which effectively act as clamps, and which allow the box to be used before the glue sets fully. Since the box will be heavy, I added some small casters to the four corners. I bought two sets of casters, 1 inch and 1.5 inch, or that's 25 and 37 millimeters. I'm showing you the tiny 1 inch models, but after a little experimentation, I elected to use the 1.5 inch wheels. They go on quickly with 4 screws, and they could be changed or removed in the future if necessary. The casters not only glide silently and effortlessly, but they change direction without any resistance. It's kind of fun to watch them swivel around like a team of dancers. I divided the box into 2 unequal compartments. The larger will hold the concrete, and the smaller will become a home for the foot pedal and electrical cords. I used a piece of steel electrical conduit for the central shaft. It's sold in 5-foot lengths, which is about 1.5 meters. I bought 1/2 inch EMT conduit, often called thin wall by contractors. I've had a lot of experience with this product. It's adequately strong and stiff for this job. No one sells metric conduit where I live, so I don't know what choices you have in other countries. Mine measures a little over 18 millimeters in outer diameter, with walls that are a little over 1 millimeter thick. I think that maybe 20 millimeter conduit might be the closest metric equivalent. I considered just embedding the conduit in the concrete, but keeping it perfectly square while the concrete sets is a real nuisance. I know this from bitter experience. I also thought it might be convenient to make the shaft removable, so I made a little box that houses the shaft and keeps it rigidly square. I glued 2 strips of wood exactly the same thickness as the conduit with a paper shim to ensure that I could remove the conduit. Then I glued a back onto the box and held it in position with 23 gauge pins. I drilled a hole through the housing in the conduit and ran a screw through both the wood and the metal. I kind of lost my sense of direction here. I wanted the screw head to be in the smaller open compartment, but I drilled the hole from the wrong side. Instead, the head is in the larger compartment where it will be buried in concrete. Oh well, so much for removability. The central divider slides into slots or dados and was glued and nailed in position. I used quick-setting concrete mix, which can be purchased in smaller 50-pound bags. I mixed it in a plastic bucket with a scrap of wood. I ended up using a little less than half the bag. I poured it in 2 or 3 stages because I couldn't guess the volume that I needed very accurately. The concrete gets quite firm in about 30 minutes, but it takes a day or 2 to get really hard. I cut out an opening in the top with my scroll saw. I measured and then drilled a hole for the conduit shaft, and then traced the shape of the sides onto the underside of the top. I cut rabbets around the edges so that the top would sit down into the box but still overlap the sides. I didn't nail or screw the top down. It seems to stay put without any fasteners. I can screw it down later if I need to. The whole base assembly, box, casters, and conduit, weighed 30 pounds or a little under 14 kilograms. This is a manageable weight, and yet it's very stable. I wanted a hanger for the motor and the handpiece that I could easily adjust up or down. I cut up an old piece of 2x6 fir construction lumber and planed it smooth. The dimensions are not very critical, but I floated in a drawing with measurements in case anyone is interested. I needed a hole that closely matched the outside diameter of the conduit, which varies a little from piece to piece. My conduit was exactly 18.2 millimeters, or 23/32 for all you fraction lovers. Both of those are very uncommon drill sizes. I ended up using an 18 millimeter Forstner bit. Because it was so short, I had to drill a hole from both the top and the bottom. Next, I drilled a hole for the handpiece. This hole is not a single uniform diameter. The top part is sized to match the handpiece itself. The bottom part is smaller to fit the flex shaft and its spring stress reliever. If you want to make a similar device, you have to measure your own handpiece. I cut a single saw kerf with my bandsaw that went through both sides of both the holes that I had just bored. This kerf allows me to put a bolt through the arm to compress the arm around the conduit shaft. Then I widened the kerf at the end of the arm on my table saw until it was about the same width as the flex shaft. This shot will hopefully help you to see how the handpiece fits into its socket. I cut out a recess on my scroll saw to create a place for the hook that holds the motor. Then I drilled a hole about the length of the threaded portion of the hook. I thought it would look nice to round the corners. This only took a couple of minutes on my disc sander, and accuracy is not very important. This is purely cosmetic. Incidentally, I tested a couple of drill sizes to be sure that the hook would fit in snugly but easily. Even so, it was a little tight, so I put in some paste wax into the hole and on the threads. That worked like a charm. The hole for the conduit shaft needed a little fine-tuning. This metal conduit is not machined like a drill bit. Both the diameter and the roundness vary a little, so some trial and error sanding was needed. All the accessories, including the tool bits, are held in place by a simple block of wood. It has a bolt that tightens onto the conduit to allow adjustments up and down. However, the wood block I used was not thick enough to accommodate the threaded insert that I wanted to use. Rather than search for a thicker block, I cut a narrow spacer and glued it onto the main block. I drilled a hole for the threaded insert, which will contain the adjustment bolt in the knob. I like to install threaded inserts on the drill press. Some people seem to have no trouble doing these by eye, but I frequently get them slightly misaligned. This setup pretty much guarantees perfect alignment. Making this small part is easier if you leave it attached to a longer piece and cut it off as the last step. I want to build an arm on the bottom of the block that will hold earmuffs, a face shield, chuck key, and a variety of other accessories. I cut the 3 pieces that make up the arm, drilled the center hole, and then glued the wingtips. These wingtips provide good security for gear like earmuffs. Off camera, I put in a couple of small screws in the wingtips as insurance. The arm is glued to the adjustment block. The hole in the arm and the hole in the block have to align, of course. I installed a couple of hooks and eyes in the bottom of the arm. One of these will hold the chuck key. I tried to make a bit holder by simply drilling a lot of holes in a wooden disc at random. Not surprisingly, this sort of worked, but not very well. In addition to my earlier assortment of small bits for the Dremel tool, I bought an assortment of new bits with 1/4 inch or 6mm shanks that will fit in the new flick shaft. I needed to organize those separately from the 1/8 inch or 3mm bits and the even smaller 3/32 bits. New big bits are not only thicker, but they're generally taller. I decided to make 2 circular trays, one on top of the other. Both simply sit on the adjustment block and freely rotate. This makes for easy access. Both trays start with an 18mm hole in the center for the conduit shaft. I turned a little plug to fit that hole and glued a strip of high-density fiberboard onto it. The strip is 1/2 inch or 12mm wide, which seemed to be about the right spacing for the bits. After the holes are all marked, the spacing jig is clamped into the drill press vise and turns into a pivot for drilling holes at a uniform radius. I really liked the way this worked. A little packing tape on the top protects the wood and helps to get clean drill holes with sharp edges. Here you can see how the bit trays just drop down onto the adjustment block and arm. One knob adjusts the whole system up and down. In use, the bit trays work quite well. I can extract any bit easily without using tools. I adjust the height to put the bits where I can see and reach them very easily. There is very little temptation to set used bits down on the workbench or table. It's just as easy to put them away since you don't have to move. Overall, I think this has been an extremely successful project. It puts all the parts and accessories together in one compact unit that takes up very little space. It's extremely easy to move around, and yet it's stable. Fully loaded, it weighs about 40 pounds or 18 kilograms, so an adult could carry it up or down a flight of stairs if needed without disassembling it. If everything I need for a task, every tool, every bit, is kept together in one easy access kit that I can roll right up to my work, the job seems much less formidable and quicker. The kit actually motivates me to dive in and do it now. I'm confident that I won't have to search for one more thing that might have ended up in the wrong drawer. This tool stand pulls everything together, and it takes up less than 1 square foot of shop space. In addition, it makes the job of putting everything away trivial. It's also kind of a fun project to build. Well, that's about it for today. As always, thanks for watching.